Good afternoon, everyone. So this panel session, along with my colleagues that are going to join pretty soon, is going to be particularly useful for module developers out there, because we're going to get into pretty good detail about how to implement a module. During lunch, we actually had quite a few interesting questions, so I'm sure there'll be more now. So I'm going to try and give a very high-level overview of how to make the module, what are the various elements involved. And then we are going to then get into much more deeper dive with the panelists that I'm going to invite for each of the elements. So, as you have noted throughout the day, the UniPro network forms the basic backbone for the Ara phone system, and into which all the modules have to plug into. And if you look at this slide, the top half basically tries to show two types of implementations for the UniPro. There is the native implementation, and then there is the non-native implementation. So in the native implementation, basically, the UniPro functionality is integrated along with the module-specific function in a given SoC, so that it's all integrated under one SoC. In a non-native implementation, basically, the module-specific chip is a separate chip, and then the UniPro network bridging function is a separate ASIC. So they're discrete. What you will see in the bottom part here is the types of bridging ASICs that we have enabled, and that make sense. So the nomenclature, again, you have seen these throughout the day. The AP bridge ASIC, as you can see, it enables basically the bridging from application processor or a display unit or a camera into the UniPro network. And then the GP bridge is more for general purpose. Any other type of module can basically use the GP bridge to network into the Ara phone system. So now what we'll do is we'll kind of take a step-by-step look at all the elements that are involved in making a module. And this particular table really shows, if you were to go about doing this from scratch, what would the developer do? So the module base is an essential commodity. So module base, if you're doing from scratch, you would source the materials, and then you would machine it according to the spec that the MDK specifies. So we've kind of gotten a high-level overview of the MDK this morning, but it's a pretty detailed document, gets into the details of the tolerances, the specifications in terms of the measurements, and so on. And now moving down the list, the module shell is the next one. How would you go about it? Basically, either you would provide the enclosure outer mold lining as per the MDK, or you can also provide the enclosures that are manufactured from polycarbonate. Then there is the electro-permanent magnet. So the EPM itself is now actually embedded in the endoskeleton. But in order to interface with that, you would need the hypercore inserts so as to do the attach and release. So to make that, you would source the material, the hypercore material, and you would cut it and assemble it according to the spec, again, based on the MDK. So now we are getting into the guts of the UniPro. So the UniPro network, as you probably are familiar, has two different elements to it. There is the physical layer, and then there is the protocol layer. For the physical layer, it has, again, because we are doing for the first time what's called a contactless media converter or contactless inductive coupling for interfacing between the module and the endoskeleton. So there is a CMC, which is the contactless media converter, that you would need to implement. So for that, you would not need to incorporate the inductive coils that I think Ara had shown in the morning. And then you would go design these analog circuits for the VGA, CTLE, and the hysteresis comparator circuits to achieve the functionality of communicating. And then the MIPI M5 itself, there is a specification out there by the MIPI consortium. It's a version 3.0 spec that you would need to comply with. And again, it's a pretty intensive analog implementation that one would have to go implement. For the upper layer protocols, the UniPro, you would basically comply with the version 1.6 UniPro spec and go design the RTL, then the synthesis, the physical implementation, and of course, you tape out the ASIC, the usual flow. Once you've done all these, And of course, I didn't mention in here the module-specific functionality itself, which is the secret sauce that you bring into bear, basically, right? So you would, of course, have to go implement that in the SoC. Now, once you have all these various elements, then you would have to design the PCB and then work with a contract manufacturer to assemble it. And then comes the more interesting and challenging part, which is the compliance of various aspects that are listed on the last row or there. You would need to make sure that they're all compliant from those aspects, as well as to be compliant with the Ara phone system. So that's, at a very, very high level, the various elements that you would need to deal with. Now let's look at the same thing. If you want to minimize the risk and also improve the time to market, you could go about this from a different angle, where you would highly leverage the ecosystem that we've been working with our partners to put in place. So in here, again, if you look at the base, you could actually go source it from the contract manufacturers like Quanta, who is a vendor partner of ours. For the module shell, you can specify the custom geometry that you would want, and then you can go work with partners like IDT Systems, and they can go implement that for you. For the hypercore, our partner Foxconn Interconnect will be able to provide the sourcing for you. And now, when it comes to the CMC, so we've been working with partners like Mixel, who would be able to provide the CMC IP if you wanted to take the IP and integrate that into your ASIC. MIPI M5 is another popular IP that is available out there. And again, Mixel and Synopsys and a few others like them are able to provide the M5 IP that you can take, and then that whole building block can be put into your ASIC, and you have to do the appropriate floor planning, and you can do the ASIC tape out. Likewise, for the UniPro, there are compliance-proven, tested IP that, again, you can get from Synopsys, or there are a few other guys like GDA and a bunch of other companies out there who could provide that for you. Now, as far as the PCB goes, now, once you know what it is that you're building, you kind of custom design that, and then you can work with Quanta, well-known contract manufacturer, and again, a partner of ours. They also can help you not only assemble, but then be able to do the compliance testing for you. And then the third way you could actually try to further improve the time to market and further minimize the risk is to actually use the off-the-shelf elements. So in this regard, again, we've been, we are trying to actually pioneer this in a manner of speaking. So we've been doing lots of modules, and we're trying to actually go do the whole phone system that you've seen in the morning. So we worked with Quanta as far as the module base goes. So they can actually, you can procure it from them. Shell, you can procure from IDT, and they have a bunch of these shells that you can actually customize. Again, our panelists will get into much more detail on that in the subsequent slides. When it comes to the hypercore, Foxconn Interconnect is another example, like I mentioned. Now, when it comes to the UniPro and MIPI, what we will be doing is, we actually have enabled Toshiba, working with Toshiba closely, we have enabled a bunch of bridge ASICs, the AP bridge and the GP bridge that I mentioned earlier. Those are proven, they are actually working, so you could take that, and then you could use it. Now, of course, this is going to be more of a non-native UniPro as opposed to the native, because now it's a discrete element. For the CMC itself, we've been working very closely with Mixel, and they would be able to, pretty soon enable a discrete solution as a chip that you could use it in your system. And Quanta, they are very knowledgeable in terms of the Ara phone system and the compliance aspects. So they can, again, help you in terms of the assembly and compliance checking. So those are the three different ways you can go about this. And like I said, there is varying time-to-market elements. Let me quickly introduce you to the panelists now for each of these elements. So, of course, in order for you to go implement your function, there are lots of up-and-coming module developers out there. So we've invited Brian Lee from Highway 1, which is an incubation company. And for the module shell, IDT Systems CEO Peter Wood is here with us. And for Foxconn, we have Jason Chou, who is the senior R&D manager. And as far as Toshiba goes, Eugene Chang, who is the senior biz dev manager over there, joins us today on the panel. And from Synopsys, we have Hezi Saar to talk about the UniPro IP and a few other IPs that are available. And finally, from Quanta, Dexter, who is a senior technical director, who will also be on the panel.
Developing physical products isn't easy. Making 1 or 5 prototypes isn't that bad. But when you want to scale to 10,000, 100,000, or even million units, it's very hard. Maybe that's why they call it hardware. So that's where we come to help. I'm Brian Lee, Senior Electrical Engineer at Highway 1. We're a hardware startup accelerator backed by PCH. And there's not very many accelerators out there that have a backing of such a large manufacturing company. So who are we? Highway 1, we invest in roughly 20 to 30 early-stage startup companies. We give them $50,000 in cash in exchange for 4 to 7% equity. Our program is 16 weeks long. We provide each company their individual workspace and unrestricted access to our prototyping labs for you guys to develop our modules. In addition, we provide engineering and design support through your development program. We give manufacturing exposure. We also do pitch development. We'll help you refine your story to tell the world who you are, the product you're developing, and why people should care. And lastly, we have marketing and PR support for when you launch your company or launch your crowdfunding campaign. But what really separates us from the other accelerators and incubators out there is our engineering expertise. We have 2 mechanical engineers on staff. I'm the electrical engineer, and we have a designer as well. We come from a broad range of industries. We have consumer product design experience, commercial, industrial, as well as medical. And part of that manufacturing expertise comes from PCH Shenzhen. And for those who don't know PCH, we design custom manufacturing solutions for some of the world's largest consumer brands on the market. So we'll take all the companies to Shenzhen for 10 days, where you'll visit some of the factories in the PCH network. So you'll see where plastic parts are injection molded. You'll see PCB assemblies, places where boxes and manuals are printed, as well as kitting and fulfillment centers. In addition to visiting China, part of the program will send manufacturing and process engineers from PCH Shenzhen to San Francisco to work with their startup companies. And all this after 16 weeks of blood, sweat, and tears and working late nights in our building. Everything culminates in our capstone event, which is Demo Day, where companies will pitch to a group of investors, press, and industry experts. So far, there have been 35 companies that have come through Highway 1. 9 of them have been led by a female CEO. And in total, they've raised $38 million in financing and crowdfunding campaigns. So I'm about to go through a few of the companies that came through Highway 1. First is Sixth Sense Technologies. They developed a handheld modular test equipment for field service technicians. And they came into the program with essentially off-the-shelf development kits wired together and clay models of what the mechanics would look like. We worked with them, and as you can see, there's some of the iterative prototypes. We got them to what you see at the very left there is a integrated, looks like, works like prototype. And what you see there is actually an integrated, thermal imaging sensor. And that's where something I could see be integrated into an Ara module. Another company that came through here, through Highway 1, is Flick. They entered with a prototype you see on the left, number 3. And they worked with us to refine their electronics as well as the mechanical assembly that you see on the very right. They exited the program and we're pretty darn near close to design for manufacturing. And they actually have an active Indiegogo campaign that, as I checked yesterday, raised over $500,000. Another company is Drop. They entered with a hacked up kitchen scale, and they exited the program, worked with PCH, and within 9 months, they were in the Apple Store on their shelves that you could purchase. Lastly, Navdi. They make a heads-up display for your automobile. They entered the program with a shoebox-type prototype. They exited with an integrated prototype that they were able to use to raise a multi-million-dollar financing round, as well as a multi-million-dollar crowdfunding campaign. So we invite you to join us. We are looking for a great team, an exciting business, and a compelling hardware prototype. And what we can help you with is ensuring that you deliver real value to your customers, that it's delightful to use, and it can be made at scale. I get asked this a lot. What are the acceptance criteria? Well, we look for a minimum of 2 people on the team. Ideally, one is very technical, preferably an engineer. It could be mechanical, electrical, or firmware. It really depends on what kind of product you're developing. And lastly, you must be willing to commit full-time in San Francisco during the duration of the program. In terms of the product, we look for a compelling hardware prototype. Obviously, the development kits haven't been released or is about to be released at the end of the month. So in terms of a prototype, what we're looking for is something that demonstrates that the device you're making can be realized in an Ara module. So going back to 6 Sense, that thermal imaging unit, it would be nice to see if you can get it within the size that fits in one of the Ara module footprints. We also look at the market opportunity. We want to see what are the potential of this device you're developing. And lastly, we're looking for user validation. We want to see that you've been able to get prototypes into users' hands and feedback and really ensure that you're developing a product that people want. So if you're interested in applying to Highway 1, please visit our website. There's a lot more detail there. But in generally, get a pitch deck ready, send it to us. We'll send you a list of questions that you'll answer, and we'll begin the due diligence process from there.
Hello, everybody, and hello to all those people out there on Google Hangouts. IDT Systems business is very much focused on designing products around consumer needs, and specifically delivering customized and personalized products, primarily, but not exclusively, for the consumer electronics industry. We're vertically integrated by design. The market is fast and furious and continually reinvents itself, as you know. But our customers actually work inside our business and are part of the production manufacturing process. We provide the customer with the tools to create the look and feel of the product. They choose, they decide, and they actually create their own shell, their own look and feel. But as we know in life, everything starts very much with a blank canvas. As you heard earlier from Ravi, shell maker apps provide the tools to actually create this. And through the use of the shell maker apps and the Ara configurator app, consumers can create and order shell kits on any Ara device. Access, of course, is all day, every day, very much anywhere, anytime. So IDT Systems puts manufacturing at the disposal of the consumer to seamlessly access our production and print management systems through the internet, whether it's in store or online. Every order is an MOQ of 1. This connectivity really is the key that empowers consumers through the user interface. The user experience is designed to make the process interesting and an adventure. And you guys know that this is no mean feat. It takes a very serious commitment to create these fully functional tools. So Project Ara's food trucks will have access to the internet, and we're using the Shellmaker apps. They will actually interface with the print management system, taking the consumer's order into the print mode. The transfer film is printed, loaded into the transfer press, and the images are actually created on the shell in some 3 to 4 minutes. The process complete and ready to assemble into the module and into the endo. Should you not be able to find an Ara van around 1 p.m. to 4 p.m. siesta time, our system has this covered. You can actually go online with your Ara device, or any device in fact, using the Shellmaker apps, create your own custom shell kit. At the checkout online, you can pay and add your delivery address, and the order is complete and ready to process. This order is directed through the print management system to the central fulfillment operation at a distribution center, probably on the island. It will be produced exactly using the same process technology and consumables, and shipped the same day to you, or perhaps as a special gift for somebody that's important in your life. In summary, our deliverable is the production solution that images the shell, the consumables, which includes the transfer film, the blank shell, and the inks. And when I say the blank shells, these are produced in a mass production process. They're actually molded. And I guess the most important interface here to make this seamless is our print management system that connects Google's Ara Shellmaker into the RIP file ready to print. With all high spec quality products, there are key elements to the production process. Polymer, the choice, as you guys know, is vast. Choices are made on the basis of the performance requirements. For this particular application, we use a SABIC product called Lexan 1414 because it's thermal and its mechanical properties. It's a very high spec amorphous polymer that was originally developed for parts in the space suit. The molded surface is actually coated with our proprietary ink receptive system. Tolerancing is very critical to achieve high image quality and surface performance. The inks are translucent, they're CMYK based and are water based, so we do look at sustainability through this process as well. This ink type, interesting enough, was originally developed for the decoration of silk products in northern Italy some years ago. This shot here, you can see the film being printed. The film the coating is also water-based and recyclable. This is actually the printed medium. We reverse print on the film, and the printed film is pin registered into a vacuum chamber. So the tray is actually placed in the transfer press, which has a transfer temperature of around 123 to 135 degrees C, depending upon the ink range. The color, the temperature range is pretty much addresses the transfer temperature of the inks. The tray, the film it softens in about 7 seconds, and the vacuum kicks in and pulls the printed surface the printed surface of the film into intimate contact with the surface of the shell. And on the right here, you actually see the film at the completion of the transfer cycle. So the interesting part here is that as you increase the temperature and the heat in the transfer press, the actual surface, the coated surface, starts to become, it opens up and starts to become porous. And when it reaches the transfer temperature, the inks change from a solid state actually to a gas and move from the coated film into the shell. The system actually is not a surface printing technology. It puts the inks into the surface of the part for up to 10 to 15 microns. And as you'll see, as you have seen with examples of the case, there are some, it gives a very high resolution, very high quality, and it meets all of the consumer electronic specifications from a performance perspective. It may seem pretty complicated, but one of our missions was to make the process very simple so that it could be operated pretty much by anyone, anywhere, at a very low level of training. Behind the system, our product development crew will take module developers through the design and manufacturing process, creating the shell for your module. You may also be comforted to know that though fulfillment is not taking place if fulfillment is not taking place at one of IDT's global fulfillment operations, our PD crew encompass the deployment group, and this group actually provides training on site as a key part of the knowledge transfer, standard operating procedures containing preset processes and color profiles. They make the operation simple, fast, and effective. And of course, behind all this, we have a system maintenance program that actually contributes to achieving a consistent visual quality and shell performance. In wrapping up here now, behind the IDT system is a mature vertically integrated operation, and we deployed over 720 systems in some 57 countries in the last 9 years. Our people are very passionate about what they do. Continuous development is very much a part of our service to customers. It's a fascinating process. We've actually been working with the project Ara before it had a name, and I have to tell you, these guys are great. The project Ara team is amazing, and it's just been an exciting adventure. Thank you very much for your time.
Good afternoon, everyone. This is Jason Chou, representing the Foxconn Interconnect technology to introduce module insert and the EPN for module developer. We will start from the EPN and module insert introduction with design and the material selection, and then we will provide you what's the Foxconn offering about the standard module insert and customize the module base and insert. Also, we will touch a little about the module insert mounting with the Foxconn content information. For our phone, the goal is not just a modular phone, it's a sexy phone. So the handle and the module need to meet some ID requirement. In traditional way, the device, the module usually secure by some kind of mechanical feature. For example, like the latch, like the screw, or kind of connector spring the friction force. but this causes kind of ID concern. Also, it may need more space for that. Ara phone take the further step to adopt the EPN concept using the magnetic force. For the this one gives the endo and the module a good look. Also, magnetic force gives the good user experience when inserting the module. Look at this one, that one, kind of kissing. Okay. Foxconn work with the NK Lab, New Deal Design, and the Quanta to develop the EPN and the module insert, including the design analysis and the manufacturing for Spiral 2 phone system. I think Ara already mentioned in the Spiral 2, the EPN already moved to the endo side. So the counterpart insert is mounted in the module side. So that will generate kind of the holding force between the insert and the EPN, the pole. This force at the attached state secure the module in the endo and the various the user condition. But the other way, in the release state, this force keeps the module from falling off from the endo, but easily removable by user. In the left-hand side shows the real EPN and the insert set. That's a big picture. But here, just show you. This one is the real EPN and the insert set, or just a Jetfish just received this week, okay? But the other side shows from the EPN and the insert set. This one, still small, okay? That's the kind of the teamwork with the support company come out of this one. In the development stage, all EPN and the module insert design need to go through the magnetization analysis to make sure on of the switch function. Also, the magnetic force analysis to meet the holding force requirement. The left-hand side shows the analysis model with the results of the magnetic flux density contour with direction. This case is 2 sets of the EPN with insert at the attached stage with the different gap. Also, this one will give us what's the holding force. The other way, we also evaluate different kind of material for the module insert. The chart in the right side shows the holding force versus the gap when considering the hypocal material and the stainless steel material. So far, hypocal material give the best the magnetic performance and to be able to meet the holding force requirement. What Foxconn can help the module developer? First, Foxconn offer the standard module insert, like the module insert 1. This is for the 1x1 and the 2x2 real module. Also, module insert 2 and the 1x2 module insert L shape. This one both are for the 1x2 module. Also, there is a front module insert. The table here shows the part number, part name, material, and lead time with the roughly cost information per DevCon request. Due to the different application, it may need more module space with the different mechanical feature. So this may interfere with the current module base and the insert space. Foxconn can work with the module developer to customize the module base and the module insert, including the magnetic force analysis. Because any actual mechanical feature may cause the magnetic flux leakage to affect the holding force. There are two examples here. The first one is 1x2 3G module base example with the different kind of mechanical feature. The other one shows the 1x2 module base with and without the insert for optical module. You may have the question about the mounting of the module insert. In MDK, there's an example to mount the module insert to the module base and called the mounting insert for 1x2 module. This one here, called mounting insert, is a kind of aluminum and laser weld to the module base to enhance the module insert bonding for space. There are many ways to mount the module insert, such as the adhesive bonding or mechanical holding with the necessary reinforcement structure. But overall, it's necessary to need to minimize the impact on the holding force because any actual mechanical feature may affect the holding force. But this one, we can solve just pay attention to the material selection. Finally, if you need more information about the Foxconn offering, you can contact Foxconn at ara-inquiries@mail.foxconn.com. Or you can contact our project manager in US, David Chang, or product manager, Pete Lin, in Asia. This including the standard module insert, customer drawing data sheet, or customize the module path, insert, or based analysis design, DFN, or manufacturing support. Also, some other lead time and the pricing information. Thank you for your attention.
Hi, how you doing? Yes, as Srinivas has mentioned, I'm in the semiconductor business, so we talk about chips now. And as part of your Toshiba, we've been working with the Ara platform for about a year now, maybe a little longer. And we want to make the ecosystem work. We want to make you guys successful. And so I'm here to talk about the bridge chips in general. So hopefully this agenda will help you out. We have decided, basically saying that Srinivas had mentioned earlier that this is probably the easiest way, the fastest to market way to get your module into the market. And we believe that the two chips here will help you with that. On top here is the AP bridge, and that's basically to handle the application processor, display, camera, and mostly the high-speed stuff, right? So you have the CSI, DSI going into the UniPro. The bottom is the GP bridge, and again, that's actually the other type of signals that we need, a little bit slower, HSIC, SDIO. So first, a little bit about the AP bridge itself. The AP bridge, actually, I've seen earlier this morning, this is actually also referred to as the HS bridge. So basically, it takes the high-speed interfaces and bridges them over into the UniPro network. It's based on the ARM Cortex-M3, and so it's very flexible. According basically on the firmware discussion earlier, you're able to go in and do things with this bigger processor. Again, it's for the CSI and DSI. Showing a little example here of what the AP bridge is possible in the configuration, either as a camera or a display. You can use a 4-lane for CSI2 for the camera, or and for the display, you can use a 4-lane DSI for the display. there's also enough bandwidth in this processor to handle sound, audio codecs, and whatnot. And all that bridges over to the UniPro network and into the switch IC on the endoskeleton. The other device, the GP bridge, is a general purpose bridge that bridges the slow signals into the UniPro network. Here again, the ARM Cortex-M3 could be used to handle all the packetization of all your interfaces here, your signals. An example here with the Wi-Fi and Bluetooth module. It's hooked up to the SDIO and also to the EORT and a GPIO interface on the GP bridge. And all that signals goes through the UniPro bridge into the network, into the switch IC on the endoskeleton. A little bit about the switch LSI. Most of you guys probably won't actually even deal with this from our procurement standpoint, but a little bit about this is the switch actually has 14 unipoles. To each port contains 2-lane transmit, 2-lane receive, each lane supporting 5.8 gigabits per second per lane. And basically another view of this is it basically is just a switch device. You have 14 endpoints even able to cross to each other. It's actually handled through the I2C by a supervisory controller. And basically the backplane, the backbone of the endoskeleton is this particular switch. And altogether, you see this in a configuration, very simple, high-level view of what in our platform will look like, with the switch being in the middle and the various bridges on the peripheral. So for an example, your camera will pick up an image, it gets processed into CSI2 package into the AP bridge. The AP bridge puts it into a UniPro packet, sends it into the switch, and depending on where it has to go, if it's a JPEG stream, it probably just goes directly to the display. So the switch sits it over to the other AP bridge hooked up to the display. The AP bridge of the display will depacketize that packet and sends it into the display, and you see the image from the camera. So that's a very high-level view of what it looks like. A little bit about the contactless inductive interface. The first generation ASICs that we had actually is a direct contact. The next generation is actually an AC contactless interface. It's basically a gap. We talked about this earlier this morning, 0.1, 0.2 millimeter wide. It transfers across this gap, jumps over to the receive side, and then it forms back into a perfect eye diagram so that it can be used in the switch or in a module somewhere. Okay, so our next generation devices will have this AC contactless. In fact, next diagram here will give you an overview of what the roadmap looks like. We're currently using the Inspiro 2, the DC contact, or the direct contact with the spring pings. Those ASICs are available currently being used in Inspiro 2. Next series of parts coming out will be the Inspiro 3 with the AC contactless, and it's coming out in February, basically. We're doing validation right now. And the commercial samples we're looking at in July. Okay, I don't have the part numbers for that, so it's all TBD for now. The one thing we're also improving on is the number of C ports on the AP bridge. It's gone from 32 to 44. We're probably going to stay with 44 as being the amount of C ports that we will have on the AP bridge. And being part of Ara, I was thinking this is actually a side project for me because Ara itself is just a really cool program, and I've been working on the starter kit for fun, actually, so it was a side job. The idea here is basically to create a module so that users can actually go and interface directly to the Ara platform. We actually have a GP bridge on this, but a 1x2 module with our USB 5, and it goes to a micro USB connector. The idea is to have, it's not really to replace the big dev board. I mean, this is just another tool for the developers we're thinking of. And the idea is basically to have a developer's application board and maybe just have it directly connected to the starter kit. And the idea here is basically, it not only is just a USB module, but it also has the SDIO, UART, SPI, I2C, all these signals that's coming off the GP bridge. We're actually going to have holes on the PCB board for them, for users to be able to take out and monitor if they have to. The other thing is also be used as an existing dongle, any kind of USB dongle for data collection. And actually, one of our board partners, eInfochips, delivered my board yesterday afternoon. And last night, I was really busy in my garage putting this together to show. So this is the starter kit. Yeah. So I have a starter kit right now. I'm going to have to test it when I finish here. And of course, all this information is on a home page. You just have to register. You can get content such as, and we alluded to it earlier, block diagrams, reference modules, and of course, engineers' favorite, data sheets. Okay? Thanks.
I'll be talking about how we can accelerate our module design. So first, I want to a little bit provide you a quick intro into what Synopsys is. So we are a company, a leader in electronic design, automation, and semiconductor IP. We deliver software, IP, and services to help engineers such as yourself to address your design verification system, all the manufacturing challenges, effectively taking it from idea to production silicon and providing you the abilities to do that in the most effective way. We're established provider, about 2,500 IP engineers deployed worldwide, all developing the most advanced standards and specifications. And really, we have a mature solution that allowing you to get into production very quickly. So really what I'll be discussing today is really the approach that you can take in order to accelerate the Ara module design. And this is effectively allowing you to start prototyping very quickly using our IP prototyping kits. We have a variety of IPs that can be used in an IP prototyping kit and also in IP software development kits. Both kind of tools allowing you to start immediately with a proven reference design that has a pre-deployed configuration for the IP. So if you are a hardware engineer and you want to start, for example, implementing your USB interface or Uniport M interface, you can start with that and really quickly and easily change the configuration to check trade-offs, design trade-offs. If you're a software engineer, you can use this kind of kits as targets for you to start your software development, start your test and debug. These are just a few tools that allowing you to get started very quickly with the design. And once you're ready and are ready to move to production and actually get an ASIC design, we have a broad IP portfolio that you can select from. So it's like a supermarket, depending on what you're looking for in terms of the chip that you're designing for the module. You can select the right IP that is best fit for you in the right foundry and process node that you are targeting, and that you can select, use that in a variety of abstractions. So you can get the IP itself, you can get the physical layer, you can get the digital implementation, or you can get the complete IP subsystem. The complete IP subsystem allowing you to get both the physical layer, the digital controller, the software, and all the environment around it, and really to simplify things in order for you to implement the complete silicon. So these are the variety of Ara modules that can be created, and believed in the past few hours you were all exposed to what is possible. But these are just a few of the modules that are being considered right now. We're working with some of the vendors developing Ara modules today and getting the ASIC done. For example, on the top left, you can see the application processor module. This is the one that really receives the image sensor information from the camera module, and this is the one that transmits all the images to the display for it to be displayed. This also interacts to the storage module. We've seen a presentation from Faison about UFS. That's the one over there. And of course, this is only limited by the imagination. This is really where you can create and innovate. But the common denominator for all these modules, of course, is Uniport M. And Uniport M, as was already talked about before, is consistent of two specifications, MIPI M-PHY and MIPI Unipro. So when we look at the implementation itself, we call it Uniport M. This is a chip-to-chip interface that provides a reliable link between module to module. And when we look at the connectivity itself, you have the medium, which is eventually going to be the contactless media converter. On top of that, you have the MIPI M-PHY, which is responsible for serialization, encoding, and really electrical conversion of the digital signals into the other side. And then you have the Unipro IP, the Unipro controller, which is effectively a layered implementation of multiple layers, really very close related to the OSI. So there's a PHY adaptation layer connected to the M-PHY, but on the top one, you have the virtual channel that is really the seaport, or where you can really transmit and receive data from module to module. So the innovation itself comes from developing the application-specific protocol that sits on top of Unipro. When we look into this two-step approach in developing our module, you can start by prototyping. So you can get a prototyping kit. So for example, IP prototyping kit that allowing you to get the controller and PHY all together from Synopsys, for example. You can get a variety of more IPs depending on what you're really planning to do. And of course, Uniport M or Unipro and M-PHY all together are required for you to connect to the outside world or the module to module. But in addition to that, the FPGA allowing you to really develop the application itself. This is really the secret sauce, the innovation, really what you want to create here, and allowing you the flexibility to change the hardware, do some design trade-offs, and also develop your software. Once you're ready with your proof of concept and you're ready to move to an ASIC, so this is what you see on the right-hand side. You have the contactless media converter, but on top of that, you have your SoC or the IC itself. I'm showing here more of an application processor, more complex one, which has Uniport M. But on top of that, you can have multiple applications. The first one is JEDEC UFS. That's the mobile storage that really sits on top of Unipro. But you can have additional applications, so display interface, camera interface, and additional data to receive and transmit from that module to the other modules. And of course, you can interact to other IPs and other SoC that sits on that module. In addition to this kind of approach, we are also helping customers to get to market faster, and we can help with using our design services team and really help you get from idea to design, or really help you interface to the Unipro as well. So this is an example of our DesignWare IP prototyping kit. This is just one of the kits that we're providing. This is available for a variety of IPs such as USB, PCIe, UFS, for example. This is really allowing immediate hardware and software productivity, because it's allowing you out of the box a full implementation of the interface itself. It's a proven target for early software development, and really pre-optimized, preloaded. So you can start going and running with that very, very quickly. You can see on the left-hand side, we have an FPGA prototyping board, which is called HAPS DX, and HAPS track connector that allowing you to connect to different kinds of PHY boards. On the right-hand side, we have an ARC software development platform that allowing you to process the information that is received from that IP prototyping kit. An example for that, and it's probably one of the more useful use cases here, this is a designware IP prototyping kit for MIPI CSI2 host. MIPI CSI2 is a protocol that's allowing you to connect to a standard mobile CSI2 image sensor, to an application processor, or a bridge processor, or any IC that would like to receive the signal from the image sensor. So as you can see, you have two blocks over here. In the middle one, you have the HAPS DX prototyping system, which is really where you can have the MIPI DPHY. This is the physical layer to connect to the image sensor. Connecting to that, you have the CSI2 host controller that receives the pixel, that receives the signal from the image sensor, depacket that, and really send that through the bridge to the AXI bus. The AXI bus connects to the software development kit, so that's where you can really connect to any CPU that you have, or to the ARC CPU, for example, to process the image that is received. So it really depends what module you want to create, but if you are envisioning a module that connects immediately to an image sensor on that module, this is a very quick way to get your hands on a complete IP subsystem that allowing you to connect and get the image and do some kind of processing to it. And the last is really the broad IP portfolio that we can provide. As I mentioned, we have a variety of IP, and depending on which SoC you're envisioning, you can select from PCIe, DDR, USB, MIPI CSI2, DSI, UFS, and of course, Unipro and MPHY to enable you to create the ASIC that you wish. So we provide the full IP portfolio, which is silicon proven, allowing you to get to market very, very quickly. And with that, I can conclude my presentation here. If you want to learn more, you can go get more information at Synopsys.com. And of course, I'll be here more to answer your questions. Thank you very much.
Good afternoon, everybody. In this session, I would like to talk about two things. First one, I would like to talk about what kind of service Quanta can provide you if you are interested in engaging with Quanta for the Ara module development and manufacturing. And the second part is that since we have already developed 12 Ara modules for Spiral 2, so I would like to share some design considerations, which I think is also important for you. Okay, so this table looks complicated, but indeed it's simple. So Quanta as an ODM, we have two parts of a service. The first part of service is design. The second part of service is manufacture. For the design part, we have the engineer center in Taiwan, which we have more than 5,000 engineers. And for the manufacturing part, we have 3 manufacturing sites in China, which we have more than 100,000 employees. Okay, so you can see that there is a two extreme on the rightmost side and the leftmost side. So one extreme is EMS, which means that we only do the tooling and the manufacturing process. So for all the other steps, we expect our customer to do. So on the other end, for ODM service, we only require the customer to deliver us the specification and the application which the customer wants us to bundle with the product. We will do everything else for you. We are flexible, so we can do any R&R in between ODM model and the EMS model. So just take 2 examples. The first one is typically we say JDM, which means that we'll do schematic, layout, and validation for our customers. And another one is the EMS plus, which means it's EMS plus the manufacturer testing program for the customers. So it really depends on what kind of service you require. We are flexible. This slide shows roughly the schedule and the resource level we estimated for the module development. So typically for a complete project, we expect 3 development cycle, which means EVT, PVT, and EVT, DVT, and PVT, which is very typical. But for the small project like Ara module, we believe we can reduce to 2 stages, only EVT and DVT, then we can jump into the MP. So I list a 20 weeks schedule, which is regular, but please understand that the schedule and the resource level itself is very specific to the features of the module. So this is only some very rough estimations with a standard process. Okay, so following I will talk about something about the module development. So here I list some dimension of a standard module of Ara, which is 1x1, 1x2, and 2x2. So when you begin to plan to develop an Ara module, so the most important thing is that which dimension you want to fit in. Okay, so please remember that there's a glue logic, like a bridge, like SPI flash, and like a wake-up detect circuitry, which is if you don't have a native UniPro interface, then you need to consider then and deduct from the area which you need. So for the 1x1, you got a 21.74 square plus 4 space. And this space you need to accommodate a module base, a PCB, a protection shell, and a decoration shell. This is the 1x2 module. So the dimension is 44.74 by 21.74 by 4. And this is 2x2, the biggest one. So the dimension is 44.74 square by 4 millimeter. Okay. So here is the most important design consideration for mechanical, which I think we need to highlight. Okay. So everybody knows that UniPro is the core of the Ara structure. So the performance of the UniPro and stability of the UniPro bus is the most important things for this platform. No matter it will be spring type or contact type, the tolerance between the interface block of the module and the interface block of the endo need to be very well controlled to guarantee the functionality and the performance. So in our experience, the assembly process is most important because the tolerance of the plastic injection, the tolerance of the PCB is pretty much industrial standard. So the only thing you can do is try to develop an assembly process which can minimize the impact of those deviations. So what we have done is that because we need to make sure the interface block align with the base of the module base, the bottom of the module base. So what we have done is that we make an adjustable datum, which means that the PCB is not directly attached to the module base. We use the liquid glue and the fixture to make sure that the interface block align to the bottom of the module base and adjust the thickness of the glue to accomplish that. So this is somewhat a little bit complicated, but it's necessary to guarantee the function and the performance of the interface block. This is the glue logic I mentioned. So because, please take care of this part when you doing your design. Okay. So let's talk about something about the design consideration of EE. The first one, the AP module should reserve ADB debug port, which I mentioned this morning. And the second thing is that because they are firmware inside AP bridge, so please reserve the UART, the serial port, to download and debug AP the module. And the third one is that the AP bridge and the GP bridge do not have many GPIOs. So if your function require many GPIOs, please remember to add IO extenders to accomplish that. The next one is that to increase the space efficiency, we have a couple modules using the RegFlex. And the RegFlex is basically weak, especially on the FPC part. So please design a very careful rework and the production process for it. And the last one is that the GP and the BP bridge only support HSIC, which is not very common to most of the ASICs. So, but most of the ASICs do support USB. They are compatible, so please, in that case, you need to apply HSIC to USB bridge. Okay, so the last one is the certification. I don't want to go through the detail. Basically, you need to follow all the safety, environmental, and the reliability test. It not necessarily will be included in the Google certification process, but it's actually very crucial to make sure you deliver a quality product. So in that sense, if you need Quanta to help on this, we have a big lab which can help you. So thank you.
So we're going to do the questions from the internet feed first. So question is from M. Turkett, and the question goes to Synopsys. Will their development kit support a contactless interface directly to a real Ara endo? Example, Ara-focused dev kit, not just a generic one.
Okay, so the question was about the contactless media converter. Synopsys does not have a contactless media converter yet supported. I think it was referred to Toshiba, I think, as the one. So our kits that are provided right now for IP prototyping kit include only the M5 with the electrical connections. So that's the only one that we can support today. Do you want me to?
Yeah, I can add a couple things to that. Basically, you're right. I think at the moment, if you want an immediate solution, Toshiba bridges have built-in contactless media converter. However, we're also working, like I mentioned, with Mixel, who's developing CMC chip, discrete chip, that should be available hopefully soon, and that would be alternative provision as well. Okay, let me see. I'm going to take, I guess looks like we have some questions from the audience, so we're going to start with, please. I would like to request, please say your name, affiliation, and then the question, please.
All right, sure. My name is Terry, and I'm one of the module developers. And I had a question for Toshiba, actually. You demoed a starter kit, and I was wondering if that was available for other people who may not have access to the developer.
Yeah, actually, we just started that starter kit, so I need to test it and make it available. So, yeah, it just came back yesterday. I don't know if it actually works. I gotta do some due diligence on the board.
I really like the concept, especially since it seems it may be sufficient for some module developers' needs, as opposed to like the full-blown.
That was the idea. Maybe it's sufficient enough, but I think we want to try with the big dev board first. And I think that's probably the more proper way of doing it. And then it's just another tool, a toolbox that we want to put in to help the developers. Yeah.
All right. Thank you very much.
Sure.
So Eugene doesn't want to give the address of his garage. Next question, please.
Yeah, Mike, I'm one of the module developers. I have a couple of questions on Synopsys and also the availability of the parts. Synopsys, are you supplying ASIC design tools that can be used to design the chips? I have a couple of IC designers on our team. And also, if the, excuse me, I don't remember I guess we'll just go with that first.
Yeah, so Synopsys, I mean, our core business is providing EDA tools. So yes, we can definitely help you with that. I'm not the right person. We're focusing on the IP side here, but definitely we can connect you with the right people.
Okay, what kind of pricing do you know it is on those tools? Because they're usually very expensive, that's why I asked.
Yeah, I'm not involved in that, but we can connect later on. I can get you in touch with the right people.
Okay. And on the other side also is, you mentioned there's going to be there's like generic parts or standard parts that we can design modules out of. And will those be available, like a parts list of pricing and availability, kind of like you order from DigiKey? Will we be able to design a module, or are we going to have to like go out and get quotes and all that kind of thing?
Yeah, so I think, like I was showing in the picture earlier, right? The components that you would need are, as far as the ASICs go, the AAP bridge, GP bridge, you should be able to get them from Toshiba at the moment. And in order to do your own implementation, you could go one or two routes. You can implement it in an FPGA. Of course, it's going to be a little bit more expensive depending on how big your logic is. Or you could go do an ASIC yourself. So that's the way I would approach this problem. So I don't think you need to really go. I mean, of course, there are lots of passives and other elements on the module itself. Those you should be able to get them from the DigiKey, but you would have to refer to the MDK in terms of the implementations.
Right, I'm thinking like when you're in the tool chain, metamorphosis, say, and you're designing a module, can you pull down, like, look at a list of parts, their pricing, and, quantity discounts, et cetera. So a lot of times when I'm designing anyway, I like to see the price to try to minimize the price, instead of having to design it first and then find out.
Sure. That's actually a great input. We probably should consider that as we go implement. That's a consideration for metamorphosis. I know Ted is going to be talking about it in about a little while from now, so I'm sure he's going to comment about it, but that's something that we can look into in incorporating it going forward. At the moment, we don't have that.
Right, I think, especially if vendors can actually submit their parts.
Right.
Become part of the
right. Yeah, but Eugene's chart had definitely shown how to go get the AP bridge, GP bridge parts at the moment, so you should be able to get those.
Okay.
Yeah.
Thanks.
Thank you. Please, go ahead.
Hi, this is Ben Wu. I'm working on the mobile storage tech and marketing. So this question is regarding to the UFS readiness. I'm curious, actually, Toshiba is pretty leading on the UFS device itself. Are you working on the UFS module for Ara project as well?
Yes, yeah, I don't know if you saw Sadhu's presentation earlier before lunch. He actually said that in 2015, that is an area that we are looking at for external memory. Yeah, so that is an area we're currently looking at. I can't really comment on much about that right now.
Oh, okay. Yeah, because we do see Toshiba emphasize the bridge chip and also highlight the camera module in this morning, but I didn't see much emphasis on the UFS. So, but the other question is, so far the SoC module released based on the Marvell SoC and NVIDIA Tegra K1, those two are so far are not really support the UFS, right? So even though the UFS device or the module is ready, but the AP, the SoC is not ready, so it's the total UFS storage module readiness is not quite
and that's a good observation. I would say that it's coming out. Eventually, we will have another AP. I believe the outer platform will have another AP that will have UFS.
Okay.
I think it's the rock chip.
So the rock chip one will support UFS.
Right. So yeah, I mean, I think UFS, there is some amount of work that we are involved with. Rockchip, of course, is building the native Unipro-based AP module, and you're right, the Toshiba has the UFS from the memory point of view. Both of them can interface on the UniPro today. So the UFS itself is, at the moment, a point-to-point interface. But we are working on figuring out how to make it work in a UniPro network system. So we kind of, together with Toshiba's expertise on this, we have UniPro chairman, who is a part of Toshiba right now, MIPI Alliance chairman, that is. So we are discussing actively on what are the oddities that we need to go iron out so that we can have a solution.
Okay. Thank you.
Hello again. This one's for Quanta and for Toshiba. When you finally release the modules, will consumers be able to tweak the hardware itself and still retain the warranty within the module? Basically, will you allow customers to tinker?
What kind of customer?
Okay, this question is very easy to answer. Even our engineer, it's very difficult to tweak the module. It's so small, higher density 005 passive component. You cannot know the real value of those passive parts. So it's very difficult to tweak.
Yeah, I figured so.
But may I ask the motivation behind the question? Are you trying to see how to leverage an existing module?
I'm just trying to see if it would be possible to, like, for say, someone taking a camera module, taking it apart, and tinkering with it internally. Would Toshiba still retain the warranty? Would they allow that? Is what I'm saying.
I think it's not Toshiba question. It will be manufacturer question.
Oh, okay.
Typically, we have some kind of a mechanism to prevent user to decompose the part, and we will dig out if they do decompose, then the warranty will not.
Yeah, there. And I don't think it is anything unique to Ara, but I understand the question now. Thank you. Yeah.
Well, I was going to add that if you wanted to tweak it, you should just be a developer yourself and get the BDB and work on it, Right.
Please.
Hi, I'm Ali from Block's Modular Smartwatches. So my question is from both the panel and the Ara team. For you are trying to say there needs to be different developers. And we can think that many of these developer companies wouldn't be big manufacturing companies. They wouldn't have enough money for the tooling costs or the manufacturing cost of some kind of experimental modules that they're thinking about. Is there any way that our team or any of these companies thinking about to help these kind of companies other than the 100K challenge?
I think Highway 1 probably is a good candidate to answer this.
Okay, so the follow-on program to Highway 1, PCH actually has another startup program called PCH Access, where they will help startup companies like yourself with very little cash with some of the NRE, the tooling charge, and the setup of manufacturing in China. And so similar to Highway 1, if you have cash, you can pay for all of that yourself. If not, PCH Access will do an equity deal to cover some of the NRE.
Thank you.
Yeah. And also, I think Anil covered certain things like incentives for module developers in the morning, so that's another avenue you should look at as well. Okay, I'm going to take the question from the internet. This is for IDT. Do you support both conductive and non-conductive inks? The question is from Pedro.
It's a very good question. The answer is no, they're primarily non-conductive. We have been looking into machine-readable inks for a variety of different applications, particularly in the area of authentication, being able to integrate components that are machine-readable to identify items as genuine. But yeah, that's as far as we've gone.
Okay, great. Are there any questions from New York? I see some people patiently waiting over there, so I just want to make sure there is a chance. Oh. Ah. That was a teaser. All right, please, go for it.
Hi, I have a badge. This is Sukhmeet. I'm happy to see you guys, and I'm from Toronto just for this conference. So I was really happy to see what you guys have been doing. The first thing is the heat. The problem of heat is always considered a big no for the performance. How are you tackling it at that level and with the size constraints and affecting other modules with the, like if this module is more heated, what happens to the other module? The other modules, do they have a barrier around them too?
Yeah, I think let me make a general comment about that, and then I would like to open it up to the panel. So as far as the components go, especially ASICs and all that, it's again nothing unique to Ara, because when people design these ASICs, you design for a very large temperature range. Usually you go from 0 degrees to 125 degrees for junction temperature. So that typically takes care of the heat itself. Now, there are other elements in the Ara, for instance, magnetic elements. So maybe Foxconn can comment about that. And then I would also like to invite Peter to comment about if that has anything to do with the shells. But please, go ahead.
Okay, first one regarding to the EPN insert, definitely for the EPN design, the one set including 2 EPN. So possible there are some kind of interference between 2 EPN if they are on the attached stage or they are both in the release stage. That's why in the design we already implement some kind of the isolated plate in between. That's in the EPN side. But the other way, in the that's a module insert side. Definitely, at this moment, we would like module developer try to keep the standard. But if some, as I mentioned, you may have different kind of application. You may need the actual space, and that may interfere with the current insert. Then, and also think about the insert mounting. In addition to the adhesive bonding, you may add the mechanical feature. That material selection is very important. That may cause magnetic flux leakage. That's why if necessary, it's better to go through some magnetic analysis to make sure this one will not affect the holding force. Okay, but also the other way is when we use the EPN, electrical magnet, permanent magnet, you may think about, oh, how will this one affect the object? For example, like the circuit, or like the Quanta also asked a question, will this one affect the credit card because they are magnet strip? That we already go through the simulation and verify that. The distance is further away, and that will not affect the credit card magnet. That's a strip there. The data will keep there, will not erase. Don't worry. Okay. So that's the somehow just give you some answer regarding to the EPN and module insert part. Okay, but other regarding to the circuit design something, I need to hand out to other people to answer that.
Yeah, and I think question would be specific to computation, like if we play games and stuff like that, the current processors, even the iPhones and the Androids cry out loud.
Okay, because look at today, we already show the holding force and the holding force versus gap, the chart today. And kind of the reach some point, the holding force will get smaller. And also, we also, for example, we use the credit card magnet strip. That's one we run because after some distance, that magnetic field will decay quickly. So that's why it's not a big concern. Current for the EPN function, we always talk about the distance is 0.2 to 0.02. And somehow this one already reached somehow the metal surface, the roughness issue, and that may affect the holding force and also magnetic field. Right. So we think it's typically from the EM theory, somehow magnetic field somehow is cube, immerse the relation for that. Okay.
In the interest of time, I think, and lots of questions still there, but that's a good summary there. I'm going to move on to the next person here. We have actually a question from New York. Please go ahead with your question.
Thank you. It's a little chilly here, but yeah, so I actually applied for Highway 1. I'm the co-founder of a consumer electronics startup, and fortunately we get in, but that being said, we did manage to just recently close a pretty significant seed round. So we're definitely exploring the next generation product pipeline, and Ara is definitely of interest to us. So in looking at that, do you guys have any recommendations on where we should start? I know this is a very kind of 10,000-foot blue sky question here, but we're mostly focused in the southeast of the United States, and there's a bit of a lack in terms of engineering resources that operate on a high enough level that would allow us to start integrating our current technologies and IPs with the Project Ara platform. Where should I start?
Okay, let me take a crack at that. I think if I understood your question, you're saying, are there any services kind of thing that you can look into? I would say, Synopsys touched a little bit about design services. So obviously, you should consider using the off-the-shelf chips to start with, and then any IP and services Synopsys should be able to provide. Quanta, of course, has the contract manufacturer-based services. So I think those are the places I would start with. But panelists, I would please take maybe 30 seconds to answer this, and then we'll take the last question. Who wants to go? Quanta or Synopsys?
I'm not sure I really understand your question, but if you want to find the start point, I think eventually, soon the Ara modules, including the mechanical EE and the source code, will be open sourced. So you can start from there, do some minor modifications to your core applications, and that would be a good start point. As long as you can do some demonstrations, you can find some partner, I guess. Yeah.
Right.
I'll definitely reach out to all of you. So.
Yeah, I was actually thinking you want to get to proof of concept as soon as possible. That's really how I took that. So there are two ways. I think Toshiba already presented the way that you can get stuff immediately, like bridge chips, and allowing you to have this bridge IP or bridge ASIC that you need. Then you build the innovation on top of that. So that's one way to start with that. That's probably the quickest one. Right. Synopsys, as Vas mentioned, we provide a prototyping, IP prototyping kits, allowing you to build an ASIC-like platform. And we also can enable you with design services to build the IP prototyping solution that you're looking for until you get to the proof of concept, show that to investors, and you have, I guess, enough funds and backup to move to the ASIC manufacturing. That's really how Synopsys can enable you. But if you want to start immediately and get that to an endo, I think both Toshiba and Synopsys can enable you with doing that.
Yeah, we're really out of time, so one last short question, please.
Yeah, it's a quick question. My name is James, and I'm just a developer. But will we get access to the general parts, like in the sense of like if I make a wireless module, it might interfere with other wireless modules. Will I get my hands on those? Or, yeah, that's my general question. And who are you directing the question to? Who would you like? It's no one specific, but yeah, I'm thinking of ideas, and it might interfere with other wireless radios. So,
well, provided the schedule when the bridge chips will be available as engineering samples in February for the Spiral 3. I don't know if anybody else wants to jump in.
I mean, I can recommend first try breadboarding. I use that term, but try to get whatever wireless technologies you want to integrate. Get them close together and see if you have any issues with interference, any of the clocks interfere with other parts of the subsystem. At least that's a starting point, and once more silicon becomes available for this ecosystem, then you can build on top of that. But at least you can get started now with solving some of the issues that you may think you might run into.
Okay, cool. Thank you.
Great. And again, I would like to thank the panelists and the audience. So please give a big hand. Thank you. First question from Zain J. Chua. How are modules authenticated? Oh, just disappeared here. How are modules authenticated? How do you avoid rogue modules from third parties? Who would like to take this?
I think
That's the old one? Okay. So never mind. It's already answered. Sorry about that. I don't have any from the feed then. So I have some questions myself if there are no questions from audience. Bangalore, Taipei, Tokyo, if there are any, please let us know. At the moment, I don't see any. So the first question is for IDT. What gives you the confidence that IDT can handle the challenges inherent in providing the many different geometries of shells that the Ara program and its module developers will require? Thank you. Peter.
Yeah, interesting question. I guess scalability is very important, and when we start a project, we generally have a long and meaningful conversation in terms of what the expectation is, and we would tool up. If it's simple prototype parts that are required, we would provide prototype tooling, and then roll into production tooling as and when we had an understanding of the volumes. But it's as far as our process is concerned, it is totally scalable. Every aspect of our deliverable is scalable. We control it, we manage it. It's produced in-house.
Thank you. Let's see. The next question is for Foxconn. How can the insert cost be lowered? I'm sure a lot of people are thinking about the cost, especially because you showed the prices.
Okay, because now it's in the sample stage, I think two issues will affect the cost. First one is the material. The second one is the volume, because the volume may related to the current process. Because the volume is low, then the first prototype, we may use CMC to start to make the prototype. That's very time-consuming, takes time. Also, but when the volume gets higher, we can move into some parts. We can use the MIN, metal injection molding. But the metal injection molding, the tooling cost is high. So if you get a high volume, after switch to that, then that can be shared by every part. The second thing in the material part, because the hypercore possible a little higher compared to other kind of material, but maybe through the further engineer effort, maybe we can try to through the engineer effort we can improve the design. Then that may use the other kind of the material. The other way, we continue to search other kind of material and to the simulation to verify is other kind of replacement. So that's the two way we try to improve further. Okay, thank you.
Thank you. Are there any questions from audience? Looks like everything has been crystal clear. Thank you, please.
Hi. Hello, I'm Navneet. I have a query for Mr. Jason. So we are using an semi-electromagnetic material that's a permanent. It's a semi-permanent magnet material for this attachments with module with the base. So in the presence of an interference or any magnetic field, will it negatively affect the performance of the device, or will the modules come loose?
Okay. So you mean some kind of interference to this kind of the material may interfere other kind of application?
So suppose we keep it near to a speaker or some.
Okay. Yeah, that's because that's one example. That the Quanta before they have question about the credit card because you have the phone put your pocket, and credit card may be put together. So that's may affect the magnet, the strip, right? So that's for that case we already go through the simulation, verify it's not the issue because through the some distance to go to the credit card. That's one example. But typically, look at the magnetic field is decay very fast through the distance. So if it's not just approximate close to that, we don't think that's a big issue. Okay.
Thank you. I have one more question for Mr. Eugene. So it's a similar scenario. So we are using an contactless connection for interfacing between the modules and the main system. So in case of an interference from an induction system, so suppose in case of an in a stray inductive field, which is the phone is kept near that. So will it affect since the system entire system communication is happening with respect to this contactless system? So will it damage the phone or will it affect the phone in any way?
That I'm really not qualified to answer. I don't think. Well, I think we have to do some simulations there, but right now the entire phone has metal safety shields on the module side, and then on the endo side it's with metal. It's sort of a aluminum or steel.
Yeah, current is aluminum.
Aluminum, yeah, and so there's a lot of protection from stray outside interference, but we probably need to take a look at that.
Okay. Yeah, I think the distances matter quite a bit, and like you said, actually there's a lot of simulations that are going on as we design these inductive circuits, and we also follow that up with in silicon, in the lab testing. As was announced earlier today, we actually have some ASICs where this functionality is working in the lab, and pretty soon it should be in the prototypes. And the other way to look at it is the distances matter a lot, right? Like for instance, the range in which these two interfaces actually communicate is a very tightly bound range. So unless you have a very, very strong inductive field, which is quite unlikely, you shouldn't have a problem. But there is a talk that is coming up later for both your questions in terms of the compliance checks. That will go into a lot more detail about the kinds of checks that we would be doing on each of the phones. So good questions, but these are the scenarios we are thinking actively about. Thank you.
Thanks a lot. Thank you.
Please.
Hi, good evening. So as a software developer, I'm wondering how easy is it for us, because we have less technical knowledge in electronics and all that, how easy is it for us with your help to actually develop a module and get it out there in the wild? From
a software perspective?
Yes.
Yeah, so as you may have noticed, we don't have a software panelist on this part. The way I would say it is there's a lot of ecosystem would be very helpful in this case. And I think the earlier comment was very much appropriate. You would be interfacing with a lot of software folks here with which we would expect you to be working together. We also have some kind of, the MDK and the associated drivers, the firmware support and all that should give you definitely a shot in the arm in getting this out there.
Does that include like designing the hardware and the SoC and all of that? Because software writing, okay, we can pick up the language, but like if it's like designing PCBs, designing the circuits, what ICs to use or stuff like that.
I see what you're saying.
So, yeah.
Okay, I thought you needed help on software, sorry. So on the hardware side, absolutely. So there is another talk coming up, which is by Ted Bapty.
Okay.
And it's called the Metamorphosis. So that's one step in that direction where they will enable you in terms of how you'd go about designing the PCB and how can you simulate before you actually go ahead and assemble this and run it, right? So that's one way to do it. And then you have seen presentations from Synopsys where you could simulate it and you could actually test it in the FPGA boards before you commit it. Synopsys also offers design services,
okay,
which will help you design these things. Quanta has the PCB design services and assembly. I would also say, the starter kit from Toshiba is another step in that direction.
Okay.
So we are putting together infrastructure in place to help you in that direction.
Okay, sure, thanks.
Yeah, I also want to add is the MDK has a lot of references to that effect as well, right?
Yes.
There are reference designs associated with the MDK.
Yep.
You can look that up. You can take a look at the GitHub for the firmware, help you with the writing.
the software. There's also the board files that's part of the MDK itself that can help you along. You can take a look at that as a reference.
Okay, sure. Thanks.
There are various sections in the MDK that go into great detail for each of these elements. Next question, please.
Hi, my name is Duk, and I have a question about the Unipro switch.
Okay.
So in the Endo, we have a switch.
Correct.
So just curious, like what is the latency to send a packet from one module to another?
Oh, it's a good one. Well, you know, each lane is 5.8 gigabits per second. So it's pretty fast. I mean, latency. I'm going to have to get back to you on that. I think I have to look that up.
Right, because that 5.8 is the bandwidth is not about the latency.
It's not the latency. You're correct. You're going from one end to the other end, and it's pretty quick. I don't think there's a big issue with the latency at all, but I do need to take a look at that. Oh, you have that.
So I probably can give you a hint on that. So Unipro is a very low latency protocol. It actually buffers data into very small packets of about 270 bytes. That's the maximum size. So the latency of the packets remaining in the switch due to Unipro or the interfaces is very low. So it will just depend on what is the bottleneck. If there are competing resources trying to switch to the same port, for example, right? That's where the switch buffering can cause latencies. But if you have provisioned your switch and provisioned your traffic
location,
if you have provisioned the traffic properly, then the latency should not be an issue.
Yeah, I think basically it all depends on the traffic in the switch. If you have all the ports, I mean, you can have pathological case where all the ports are transmitting at the same time, competing to a given port. There is also priorities by traffic classes. So you could set your priority based on the quality of service that you want. So there are many different factors that affect your latency of a particular packet to get through. Cross traffic, like you said, priority, and where do you stand in the priority queues, what's the quality of service, a bunch of different factors affect it.
Okay, thank you. And I have another question also about the switch. I believe this network is, you guarantee that when the packet is sent, it will be delivered?
Yes.
So how can you guarantee that if like you have very high traffic, I mean, will you lose the package?
No.
No.
No, it's pretty secure. It will go through the Unipro network pretty quickly, and I don't think there's any kind of loss with that.
Yeah.
Unless you drop the phone and the modules fell out or something. But.
Okay.
Yeah, it is lossless. Of course, depending on how the scheduling is done in terms of the application software, setting it up, the various traffic streams, you could have a bandwidth hogging agent out there, but that all depends at the application layer. The switch itself is basically a hardware that is being manipulated by these application layer software, right? So it depends on how you set up the QoS, how you send these packets. The only events that may result in a loss is if for some reason your link goes down or some catastrophic event happens, right, which is not normal. But otherwise, it is supposed to be a lossless transmission. And there is variable latency depending on your priority. And the
Thank you.
traffic. Yeah. Any other questions from other sides? Bangalore, Tokyo, Taipei? Okay. Let me see. I have a question for Toshiba. I like your module developer starter kit a lot. I think it's a great idea. So it further improves the time to market for developers. Can you share the expected price range for such a starter kit? Would you license the reference design, perhaps?
Well, at Toshiba, we're just interested in promoting the Ara ecosystem. We haven't really looked at the economics of it yet. We're just coming up with the idea, and we're looking through, working through the design and development of the starter kit. We're working with our partner, and we'll have to probably get back to you on that. Yeah, but no, it's an exciting thing to do. We're very excited about offering something like this for the design community, and I think it's going to be another tool in the arsenal with the BDBs and all the other things that's going to be part of Project Ara.
Right.
We want to help out.
Yeah, because it definitely, I think there are questions about how to help the ecosystem to get their module into the market space. So I think it's a great idea. Okay, I have a question, similar question to Quanta. You know, I would imagine there'll be a lot of up-and-coming module developers, smaller startups, smaller outfits, with probably very good ideas. Would you entertain small-scale module developers that would like to engage with Quanta? And do you plan to enable any starter kits yourselves?
I think the most difficult part for small entities is how can you guarantee the signal quality through the UniPro, which is 5 giga signal. So the impedance is important, the eye diagram is important. So if you don't have the simulation tool, if you don't have a network analyzer to measure the bare PCB, then that could be an issue which you eventually cannot pass the certification. So in that way, perhaps we can have some standard program to help the module maker to let them know the signal quality and make some advices.
Right, right. And the first part of the question, I guess, are you accessible for small-scale module developers?
I don't quite catch that question. You mean personally? Or?
I hope personally will be fantastic, as Quanta.
Okay. Actually, we are open to different scale of business. So if there's a lot of small entities, we need to think about a very common approach which can reduce the effort by sharing the common platform. Yeah, which is the direction we are thinking of.
Great.
Yep.
Fantastic. Okay, any other questions? I think that looks like the end of it. Thank you all. Thanks for the panelists, please. And